these pages do we want to start with?
I think probably the one that says 6.4 exercises and applications on the right.
Okay. Okay, number one. What theorem do you use to prove congruency? Well, you direct me. Do you want to start at one, or do you have specific ones you want to talk about?
Probably just start at one. Yeah.
Okay.
Probably you could use the reflective property, maybe, but also.
Well, what we're looking for is side, 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 angle,
Yeah.
side, angle, those kind of theorems.
Probably angle side angle, since it looks like
Don't,
they've got.
you can't go by what it looks like. Okay, we know that. Here, hold on, let me take a snapshot here. You know that that angle is the same as that angle, and you know that that
Yeah.
side's equal to itself, but there's,
Yeah.
I can't tell, is that angle right there equal to that angle? I can't quite see if there's hash marks. I think there are.
Yeah, I think so.
Okay,
Yeah.
so that is side, angle, angle.
Okay.
However, yeah, no, because, yeah, actually it's not really side, angle, angle. It's if we know these two angles are equal and we know, let me point with my cursor. If we know these two angles are equal and we know this angle is equal to that angle, then we know that angle is equal to that angle, right?
Yeah.
Okay, so let's draw that. Let's use a triple hash mark. So now we can use angle, side, angle.
Okay.
And that's what proves it. There's not that many that you can use. And in fact, if we list them all, if I list them over here, we got side, side, side. We got angle, side, angle. We got angle, angle, side. Anytime you have two angles and a side, then it's proof. That's the same thing.
Yeah.
But this does not prove congruency. Side, side, angle. So be careful of that one. And then you got
Okay.
hypotenuse, length, if you have a right triangle. So I think these are the only five. 1, 2, 3, 4, 5. And a couple of them are kind of the same. That's the same. So, all right. So how about number 2?
Um, Angle side. And then would it be angle then?
Well, what other angle is equal? I don't see another angle that's equal.
Yeah.
In other words, you definitely have angle, angle, and you have that side's equal to itself, but
Yeah.
I don't see anything else. And in fact, one thing you can do when you come across a problem like this is that it sure looks congruent, but I can't prove it. Okay? Well,
Yeah.
can I prove that this is not enough for congruency? Yes, I will show you how. I can make that blue angle exactly the same as the red hash mark, and yet clearly now the two triangles are not congruent, right?
Yeah.
So having this angle only and one side only is not enough to prove congruency. So this,
Okay.
you can't prove it, none. Okay. So you have to have at least 3 pieces of information about number 3.
Okay. Side. Well, wouldn't it be none because there's not enough really to
Actually,
prove it?
you got 2 vertical angles right there. That angle
Okay.
to that angle because they're vertical angles.
Oh yeah.
Now you have what?
Side angle or angle side.
Angle, side, angle, side. Now, the way to figure this out is I got a side over here, I got a side over there, and I got the in-between angle. So that's side, angle, side. I don't go this way.
Okay.
I don't go side, side, angle. That actually does not prove congruency. What you have to do is go the most efficient way. In other words, notice that if I went this way, I would be bypassing an angle there and an angle there. That's not the most efficient way to go. But if I go counterclockwise, if I go this way, then I run into everything I need immediately. Side, angle, side. First 3 things I run into. Whereas if I got to go that way, I run into this angle here, I run into that side there, and I run into that angle there. I don't know any of those. So when you're figuring out whether to go clockwise or counterclockwise, always go the most efficient, quickest path, if you know what I mean. It's a little hard to explain, actually. But in other words, in this triangle over here, there's the side, there's the side, there's the angle. The most efficient way here is clockwise or counterclockwise. It doesn't matter. In other words, I've got these 3 things right together. So that's what I start with one of them and go to the third one. I don't go around the horn like that, bypassing all those other angles and sides.
Okay.
This one you might have to help me out a little bit with. I feel like there's some hash marks and right angle marks on the triangle below.
Yeah, there are hash marks and right angle marks.
Let me do this and see if that's correct.
Yeah.
Okay. Is that a...
So that would be angle side.
That's not... Angle side is not a theorem that proves it.
Okay.
However, this is a right triangle. There is a special theorem for right triangles called...
Oh yeah, hypotenuse. What's
length?
Hypotenuse length. Yeah.
Which means hypotenuse and one of the short sides. Okay, so there's the hypotenuse. So we got that, and there's one of the short sides. I don't care if it's equal to that one or that one. It would still be congruent. In other words, if you have 2 right triangles and they have the same hypotenuse and they have one side that's the same, they're congruent. And you do have to use this HL on this one, because notice that if I tried to go clockwise or counterclockwise, if I go that way, I end up with side angle. That does not prove congruency. If I go this way, I end up with side angle. That does not prove congruency.
Yeah.
If you have two angles and a side, yes. But two sides and an angle, no.
Okay.
Number 5. Let's see if I can see this one here. I'm going to guess that, 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 and that.
Yeah.
Okay. Is that congruent?
Um,
Are those two triangles congruent?
it looks like it if you did side, side, side.
That's right. Side, side, side. Okay. How about number 6? Let's see. We got that equals that. And what else do we know?
We know that vertical angle theorem would make those two angles congruent.
Now notice we have some parallel lines. What does that tell me?
That they're also, they
Well,
would,
let me put some letters on this. Tell me what angle is equal to what angle based on the parallel lines.
angle B is equal to angle C and angle D is equal to angle A.
Actually not. Angle B is equal to D,
Oh yeah.
and angle C is equal to angle A. Remember, when you have two parallel lines and a transversal, it's 1 equals 6.
Yeah.
Well, picture this as the two parallel lines with the transversal. A and C are alternate interior angles.
Yeah.
Okay. So now that we have that, what theorem? We got all kinds of stuff. We got angle, angle, angle.
Side angle, side.
I don't think we have side angle, side.
Uh,
We don't. We don't have two sides. What we have is two angles and one side. And
yeah.
actually,
So,
we don't need, in other words, all of the theorems that involve having two angles, that's all they have. It's AAS or SAA or ASA. Any of those prove congruency because you have three angles that are equal and one side. You know what? That doesn't prove congruency. I apologize. This one does. These two don't. I can actually give you a triangle that's got all three angles equal. Two sides are the same, but they're not the corresponding sides.
okay.
For example, if I said, are these equal? And I give you this side is equal to that side, and this angle is equal to that angle, and that angle is equal to that angle. So I actually have all three angles equal, so they are similar. They're not congruent. And I didn't mean to do it like this. Hold on. This was not very clear. But if I make this hypotenuse equal to this side, notice that I've got angle, angle, side. I also have side,
Yeah.
angle, angle. I got angle, 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 side. But the sides, that's the hypotenuse, that's one of the short sides. So those two triangles are not congruent. And I've even kind of drawn it to scale. In other words, this distance there is about the same as that hypotenuse. That was my attempt. But clearly they're not the same size triangles, right? And yet they they do follow angle, angle, side, or even side, angle, angle. So these two don't work. You gotta have
Okay, yeah.
angle, side, angle. Or if you had angle, angle, same side, corresponding side, then that proves congruency. But just angle, angle, side alone does not prove congruency.
Yeah.
Well, I guess, I mean, I got angle, angle, side. This way, I got to go angle, angle, side. And those two are not congruent.
Yeah.
So that's the one that gives most people the most amount of trouble, is the angle, angle, side when it looks like that should work. Okay, so let me scroll down here a little bit, and we'll tackle number 7. And if at any point you want to jump, because you can probably tell we're not going to get to all these problems in a half an hour.
Yeah.
If you want to jump, all of a sudden things are not working here. Try this again. Okay, now we're good shape. For each exercise, name a pair of overlapping congruent triangles. Tell which method you can use to prove the triangle's congruent. So, hold on. RU is equal to QT, or it's congruent to 2QT. And angle R is congruent to angle T.
Yeah.
So name a
And then
pair of overlapping congruent triangles.
Q R RQS and TSU.
RQS and TSU are not overlapping. They're adjacent. They do happen to be
Okay.
congruent, but they're not overlapping. How about PQT? There's this triangle. Is
Okay, yeah.
overlapping with triangle PRU. Hold it.
Okay.
PQT, excuse me, PRU. Yeah, that's right. In other words, if I draw them in different colors, that triangle is congruent with the red triangle that I've drawn on there.
Mm-hmm.
Based on what?
So there would be angle.
Let's see. Hold on. Let's label these. That's the same as that. And that side being RU is the same as that side being QT.
Okay, so angle.
What other, hold on a second. Let me take that out of there. That's a little confusing. We know those two sides are the same. Let me draw them in red. Rather than use a hash mark kind of makes it more confusing. So those two are the same. What other angle is the same?
Well, P is the same for both.
Uh-huh. And that would give you side angle angle.
Yeah. Yeah. Side angle angle.
Unfortunately, side angle angle doesn't prove it. something I'm not seeing here. Let's see, they said RU is congruent to TQ. Well, that makes this angle equal to this angle. Now, notice that this angle right here, let me draw it in red, this angle right there, because of the little triangle, has to be same as this angle right there. I'm not sure that helps us, but look at this without all the stuff on it. It's a very common problem. I just can't remember exactly how to do it. Let's see. We know that one's equal to itself. We know that one's equal. If I can prove the third angle is equal, in other words, I got to prove that angle 1 is equal to angle 2. And then I will have angle, 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 and the same corresponding side, because I know RU is equal to QT. So I can use angle, angle, side as long as I know it's the corresponding side. Okay? So I don't even think I have to prove that 1 is equal to 2. Each of those are the third angle in their respective triangles. Remember, our triangles are PRU and triangle PQT. Those are the two overlapping triangles that we're trying to prove congruent. Okay. Now, if I have two angles equal, then I know I have all three angles equal. That's all I need. That means 1 is absolutely equal to 2. And now, as long as I know that RS is equal to QT, then I can use angle, side, angle using those two angles and that side, along with those two angles and that side. Notice the side is in between the angles, which means it's the corresponding side. And ASA is always works. This doesn't always work, and this doesn't always work. But this does every time.
Okay.
If it's the side that is between the two angles, that works every time. And this is because we figured out that all three angles had to be equal, and therefore this side is between the two angles. It's between that angle and that angle.
Yeah.
All right, let's see if we have time. I may not have time to do one more. Let's see if we can quickly.
Okay.
I do have a 5:30 appointment, so I don't have a lot of wiggle room, but I got 3 or 4 minutes here. AB is perpendicular to DA, making that a right triangle.
Yeah.
And it's perpendicular to BC. So these are both right triangles.
Yep.
AD is congruent to BC. else? What's the third side that we need to be the same?
AB. Or, well, not AB, no.
Well, no, you're right. AB is the third side to both of those triangles. In other words, one of the triangles is this one. The other triangle is this one.
Yes.
And we're trying to prove those congruent. We've determined that they're both right angles. So what is it? What's the theorem?
Hypotenuse length or side angle side.
No, well, it's not hypotenuse length because we don't know the hypotenuses are equal. But we do know side, angle, side, all in a row. Side, angle, side. That is always proof of congruency. Two sides and the angle in between those two sides. All right, Jonathan, I'm going to let you go.
Okay.
And I will talk to you the next time.
Okay.
All right? Good night. Have a good night.
You too.
Bye-bye.